Hello, this is Carl Freund again with Cambrian-AI Research, and today I have Rama Divakaruni from IBM Research here to talk about chiplets. Rama is the Distinguished Engineer of Hybrid Cloud Technology Research at IBM. Welcome, Rama.
Good morning, Carl. How are you doing?
I'm doing great, Rama. Thanks for asking. So chiplets, it's a hot topic right now, right? Monolithic dies seem to be, not going away yet, but certainly there's a better alternative for many platforms, especially in the world of SoC. So Rama, perhaps we could just start with the basics. Why is everybody talking about chiplets? Why chiplets?
Okay. So let me talk about sort of the pressures in the marketplace, right? So if you think about how compute is moving in general, compute is moving to as a service model. And anything that moves to as a service has sort of two obvious corollaries, right? One is time to market becomes very important. Not that it isn't important in general, but it's accelerated, so to speak. Second is the cost of the infrastructure. There are pressures, a lot of pressures, because you now have to sort of amortize the cost with your service and keep the service continuous. Obviously, this has implications on supply lines, as we saw really accelerated during the pandemic, and we all experienced that. And at the same time, it's clear that scaling is slowing. The technology scaling that we know and love for many decades and I've made my career on, and also the cost of most advanced technology is exploding. It's like it can be hundreds of millions of dollars. So we need to do something, right? The compute demands are rising. It's consumed as a service. And the cost of the silicon is getting really expensive. So how does one go about this problem? So the reason chiplets are exciting is it sort of provides a finer grained modularity. When you get the benefit of putting everything on one piece of silicon, that's great, right? If people can pay for that piece of silicon for that workload, right? But now if there's a cost pressure and there's a time to market, then we need to come up with a way that satisfies the modern day constraints. So if you had a finer grained modularity, and if you build a collaborative model where people can contribute, and the software folks have done this, contribute to a particular value add in there, right? Then you can spin things quicker, right? So that reduces your time to market. And because you're only changing the function that needs changing at that time, it reduces the cost. So you don't have to respin the entire gizmo. You respin a subset of the gizmo. And that refactorization, the new buzzword is chiplets. Mm-hmm. So I hope that helps put it in context for why everybody in the semiconductor space really interested in chiplets.
Well, it's like, why reinvent something that's already working? You just pick it up and use it, build on stand on the shoulders of greatness of the great people that did that work and add value to it. And especially
exactly right.
Especially in the world of heterogeneous computing and domain-specific computing, the value is perhaps not in the SerDes, is not in the DRAM controllers, right? It's not in the cache. It's in the architectural innovations that you're applying, right?
That's right. That's exactly right.
So what's
All of
I what?
those are important. All of those are important, of
Yeah,
course.
you got to have them. They got to be good. But the rate of change
Yes,
there is slow, right? I mean, how long does it
that's
take
right.
us to go from DDR4 to DDR5, right?
That's right. So that
7 years?
way, yeah, that's right. So that way, it's not that every aspect needs to catch a particular train of an SoC
Mhm.
or a particular node, but they can each move at their says at their clock, so to speak.
So tell us a little bit about what IBM Research is doing in the world of chiplets. I mean, one of the problems with chiplets, I was with AMD when we did our first chiplets for the first EPIC. And one of the challenges is performance,
Yep.
uh, because you're kind of going off chip. And how is IBM Research helping that and other aspects to lower the barriers for chiplet design?
Right. So we have been pursuing this in our AI hardware center because AI is a workload where the compute demands are very, very high, right? And you see this problem in spades, right? We put out a new AIU, we announced it earlier this week, which is a contiguous SoC, but, and of course, it's a high performance accelerator for deep learning and uses state of the art, reduced precision and the like. Actually, variable reduced precision, you can check it out. But the AI hardware center has already started doing pioneering work in trying to split up such AI SoCs into chiplets. Because to maintain these connectivity and maintain the performance of this thing, you need to make sure the interconnects are right, and it puts pressure on the packaging, right? And so today, folks just buy packaging. There's not that much packaging in the US, as you know. And this is part of the reason why we are so interested in helping get innovative packaging back to the United States, right? And so it puts pressure on the packaging, but we also are lucky to have the world's most advanced state-of-the-art silicon fabrication facility in Albany. And we have, right in the middle of the pandemic, we sort of rebuilt a packaging line, right? And we're bringing a lot of our novel ideas that were in our labs on packaging technology. As you know, in the old bipolar days, when we had majority carrier devices, heat was a problem and things were in many ways heterogeneous, right? So we are bringing back a lot of these innovations that we had in the bipolar days into what with the modern context and the modern workload, right? And so we're going to bring them, we're in the process of bringing them together in our hardware thing, platforms that we're developing in Albany. Then obviously in our design and architecture platforms in our AI hardware center, and also connected to a software platform, right? Because you have to test the workloads, right? And that full stack approach is very important because you don't want to slow down the consumption model because economics is driving it, but you have to test it. So that is the internal view. On the external facing view, we are building a full ecosystem, trying to get small and medium businesses into so they can innovate on these chiplet parts, work with our EDA partners, because as you know, the silicon to packaging interface needs to be seamless to address your performance concern, right? And we of course work with our foundries to help make this happen, right? So I think this is a journey we are starting, but I'm very excited about this, as you can tell.
I can tell it is an exciting era as we move into chiplets. It takes too long to build a chip. It takes way too much money, especially as process nodes. So if I can use other technology that's maybe doesn't need to be an advanced process node, I can lower my costs. I can get to market faster. These are all great things. Requires different tooling, It requires a different approach to packaging. So if I'm a partner with IBM Research, how will I see this roll out? What will I actually do with IBM in the future that I'm not doing now?
Excellent question. So it's a strong function of where you want to play in the stack, since we are in a full stack approach. We are fully open to different business models in different parts of the stack, right? Because the hardware space, we have multiple decades of work in Albany and in our semiconductor research work over the decades. We have a strong model that works and brings innovations, and we have a good track record, as you know, right? When you go a little higher, there is this AI hardware center, and that's a different model, right? That's more like a consumption model of the innovation, right? And then we work with, say, a software company like an EDA company, but they can bring their software stack to work on our Red Hat platform, to work in these, because of the nature of compute, and it's a hybrid environment. You can't move the data. You can't move this huge design data. There are data gravity issues. So you need to work in a hybrid platform. And the EDA companies are in the process of migrating their tools. So we want to work with them. And as you know, the tools themselves need to comprehend the chiplet. So this is a very interesting change. I have not seen this amount of change in my career, right? I mean, and I did scaling. Okay. So this innovation of the business model, the technology platform, is a completely new area in semiconductors. And I'm really excited. And I think it gives us the opportunity to work all the way from software vendors for the way they currently operate, and all the way to down to the hardware. And I call it a gear ratio, right? The software moves really fast, but the hardware moves really slow. And you need these seamless gears of technology and business to work.
It seems to be happening at the ideal time. I mean, we have obviously geopolitical aspects are impacting funding and the desire to build U.S. or Western-based facilities for chip design. Meanwhile, you've got artificial intelligence coming along, demanding massive computation and creating opportunities for very specific applications, circuits. But what are the biggest challenges? So if I'm a design team, I'm of course using tools for monolithic silicon design. What are the biggest challenges I should expect, and how will I overcome them?
Yeah, I would say as you said, the migration is in its early stages, right? And I would say I'm glad you asked about design, because I think one of the things in the geopolitical thing is the non-geolocation of not just the silicon supply, but also on the talent pool, right? So I do know that 20 or 25% of the world's designers are in India, right? There aren't many fabs there, right? For example. So there is that other pressure that I think it's important to recognize also drives cloud consumption and design, right? I think it's very important to recognize that. So, but that said, chiplet migration is early. There are benefits clearly in some areas, right? We know, for example, in AI, and I was talking to a networking company yesterday, and they're like, "Oh my God, there's so much data. We love this chiplets thing. How are we going to digest all this data, right?" And clearly 5G and 6G and networking switches are also going to see this issue, and that's just starting. And we need to develop standards, and the standards are just beginning. There was the ODSA bunch of wires a couple of years ago in the middle of the pandemic, 2000 or so. 2002 this year, there is UCIe. I don't know if if things will end there. Let me be straight. I think those are necessary early steps, but I think having standards and migration of standards is important for folks to collaborate on, right? I know the early chiplets are all proprietary fabrics. And as you know, the software folks have demonstrated very successfully that open platforms are the way to go.
Mhm.
So we need to get to an open, inclusive platform where people can contribute their chiplets and their IP in some simple way. And I think there are plenty of designers in the world, or we can excite a plenty of designers in the world, right?
Mhm. Mhm.
And I'm pretty confident silicon will become sexy again.
I think it already is, but I'm weird. Yeah, as you and I were talking the other day, this idea, this vision of composable silicon,
Exactly.
the hardware instantiation of what's already happened and it happened in the software model. It all requires standards. It all requires that you don't have to reinvent the way you talk to each other, and that has to be the foundation upon which you build these platforms. And it is exciting to see the industry come together, companies that are mortal enemies in the marketplace are collaborating openly on the standardization of the interfaces. And now I think the tools need to come along, and they are from the
Yeah.
EDA vendors to support those.
Yeah, and I thank you for mentioning this composable systems, because we had a DARPA program on epochs, and it's quite amazing what you can do. There are some very interesting ideas, even the of Columbia University here that we worked with, where there is things are I would say locally synchronous and globally asynchronous.
Asynchronous, right?
Right, and so these are very, very interesting concepts, and I think I am quite optimistic. Another 20 years of this and we'll be there.
Mhm. Well, I think moving us from proprietary chiplet world to chiplet world where everything's is composable and interfaces are standardized is going to have dramatic impact on time to market and innovation. And we're just at the beginning of that journey, as you say. So, Ram, I look forward to continuing this conversation in future podcasts as we continue down that journey.
Absolutely. Thank you. Thank you.
Thank you.
Carl.
Thanks for joining us today. We'll talk to you again soon.
Absolutely. Thank you.